Dear students, today we are going to see Newton's laws of motion. I hope till now whatever we have studied, the concepts related to the motions, they are clear. Today we are going to see all the three laws of motion. Let's see the Newton's first law of motion. Newton's first law of motion states that an object continues to remain at rest or in a state of uniform motion along a straight line unless an external unbalanced force acts on it. For example, any object, if it is kept on the table, for example, if I keep one book on the table, it will remain to be there till someone comes and doesn't move it. That becomes an example of first law of motion. When an object is at rest or in uniform motion along a straight line, it does not mean that no force is acting on it. Actually, there are a number of forces acting on it, but they cancel one another so that the net force is zero. Newton's first law explains the phenomenon of inertia. That is, the inability of an object to change its state of motion on its own. As I said, the book will remain there unless and until someone else doesn't come and move it. All examples of inertia are the examples of Newton's first law of motion. Let's see the Newton's second law of motion. Before looking for the Newton's law of motion, second law of motion, let's see and understand the concept momentum. The effect of one object striking another object depends both on the mass of the former object and its velocity. This means that the effect of the force depends on a property related to both mass and velocity of the striking object. This property is termed as momentum by Sir Isaac Newton. Momentum has a magnitude as well as a direction. Momentum is defined as the product of mass and velocity of an object. Momentum is denoted by capital P. Hence, according to the definition, it states that P is equal to M multiplied by V. As momentum has magnitude as well as direction, it is a vector quantity. The SI unit of momentum is kg meter per second, while in CGS system it is gram centimeter per second. Now let's see the Newton's second law of motion. Newton's second law of motion states that the rate of change of momentum is proportional to the applied force and the change of momentum occurs in the direction of the force. Let's see. Suppose now we are going to derive the Newton's second law of motion. Okay, the derivation will come. The question can be state and explain Newton's second law of motion. In that case, you have to define the Newton's law, second law, and derive this equation what we are going to see now. Suppose an object of mass m has an initial velocity u. When a force F is applied in the direction of its velocity for time t, its velocity becomes v. Let, according to the momentum, the initial momentum of the object is mu, while the final momentum of the object is m into v. Rate of change of momentum. Rate means upon time. So change in momentum upon time, which is equal to mv minus mu, that is final momentum minus initial momentum upon time. If we take m common, it will be m into bracket v minus u upon t. As we know, acceleration is v minus u upon t, hence m is equal to m into a. According to Newton's second law of motion, the rate of change of momentum is proportional to the applied force. Therefore, ma, that is mass into acceleration, is directly proportional to force. Now, in case of direct variation, when it is direct variation, it is k is the constant of proportionality. So, F is equal to k into m into a, where k is equal to 1. So, if I substitute the value of k as 1, it will be F is equal to m into a. In SI system, the unit of force is Newton, while in CGS it is Dyne. Remember, dear students, even if the Newton is the name of the scientist, when we write down the unit, n will be always small in Newton. Newton's third law of motion. Newton's third law of motion states that every action force has an equal and opposite reaction force which acts simultaneously. Action and reaction are the terms that express force. These forces act in pairs. Action and reaction forces act simultaneously. Remember, action and reaction forces act on different objects. They will never act on the same object. We will try to understand this with the law of conservation of momentum. Suppose an object A has mass m1 and its initial velocity is u1, and an object B has mass m2 and its initial velocity is u2. According to the formula for momentum, we know that the initial momentum of an object A is equal to m1 u1, while the initial momentum of B is equal to m2 u2. Suppose these two objects collide. Let the force on A object due to B be F1. Now, after the collision, this force will cause acceleration in object A and its velocity will become v1. So, after collision, the final momentum of object A will be m1 v1 and the final momentum of object B will be m2 v2. If suppose F2 is the force that acts on object B, F2 is equal to minus F1. Therefore, As we have seen, F is equal to mass into acceleration. After substituting the value of F, we get m2a2 is equal to minus m1a1. We know A is equal to V minus U upon T. We'll substitute the value of A in equation. We get m2 multiplied by V2 minus U2 upon T, which is equal to minus m1 multiplied by m1 minus u1 upon T. T and T will get cancelled. Therefore, it will be m2 into the bracket v2 minus u2, which is equal to minus m1 into the bracket v1 minus u1. We'll multiply inside the bracket by m2. So it will be m2 v2 minus m2 u2 minus m1 v1. By minus m1, if I multiply the bracket, it will be minus m1 v1. Minus and minus becomes plus, so it will be m1 u1. If I get minus m2 u2 on the right hand side, okay, and minus m1 v1 to the left hand side, it will be m2 v2 plus m1 v1 is equal to m2 u2 plus m1 u1. Hence, when two objects collide, the total momentum before collision is equal to total momentum after collision. The magnitude of total final momentum is equal to the magnitude of total initial momentum. Thus, if no external force is acting on two objects, then their total initial momentum is equal to their total final momentum. This statement is true for any other number of objects. When no external force acts on two interacting objects, their total momentum remains constant. It does not change. Hence, when two objects collide, the total momentum before collision is equal to the total momentum after collision. Dear students, I hope you have understood all the Newton's 3 laws of motion. Now, in this full video, whatever we have studied, the definitions you are going to write down in the notebook. At the same time, Newton's second law of motion and law of conservation of momentum, these two laws, these two notes can be asked for the exam. So you have to write down these things in your notebook.